Hey everybody, so now that we know we need 0.28 grams of pulp, where is that pulp coming from? Well, I'm thinking we can use abaca, which is a very strong fiber and long enduring, and we can use this at 50%, and then the rest will be the tone tan sketch paper, which is mostly cotton plus recycled paper. So 50% this to provide much needed tanning, and then the rest is going to be abaca, 50% abaca. So 0.14 gram of abaca and 0.14 gram of the tone tan sketch paper should give us the needed amount, right? So 0.14 grams and 0.14 grams, if you amplify that amount, and say by 10 folds or 5 folds or 20 folds, and then you can then pipette more volumes and process it and pipette more volume, right? So what I'm going to do here in this case is multiply everything by 5. So the 0.28 by 5, I end up weighing 1.49 grams, right? If I have 1.49 grams then dissolved in say 200 mils of water, then from that slurry, I figured 40 mils of that slurry will give me the 0.28 required to go into the spine, right? So it's just a matter of doing the math and getting that down. Let's move on to the math of calculating the milliliters of slurry needed to pipette into the spine area of the Planet Comics. All right, so let's look at how we're gonna figure out how to make the pulp. So the pulp amount is gonna be 0.28 grams. But since it's difficult to work exactly with 0.28 grams, what we're gonna do is amplify this by fourfold. And instead of paying 0.28 grams, I'm gonna weigh 0.3 grams because you have some loss of fiber when you process the pulp, right? And that I accounted that to be about 10% value. So if you instead of doing 0.28, you do 0.3, you end up with at the end with about 0.28, right? And that, I think that makes sense. But let's just say for the math's sake, you have 0.28 grams. If you amplify it 4 folds, you end up weighing 1.12 grams instead of weighing 0.28 grams. So the 1.12 grams, you could have a total volume ultimately of 200 mils of slurry, right? The pulp plus the water are going to be about 200 mils plus all the additives, whatever additives you decide to do. That 1.12 gram of pulp is going to be in 200 mils of water, meaning that each mil of this slurry is going to deliver 1.12 divided by 200, which works out to 0.0056 grams of pulp. Right? So if 1 mil is giving you 0.0056 of 56 grams of pulp, then how many mils do we need for the entire spine, which is 0.28 grams? So we have 0.28 grams. How many mils of the slurry do we need, X, right, to get the 0.28 grams? So it's 0.28 times 1 divided by 0.0056. So amount of slurry or volume of slurry after we're done with it is going to be like this: 0.28 divided by 0.0056, and that gives you 50 milliliters of slurry. So the 50 milliliters of slurry can be introduced with the syringe sent to me by Dr. Paul. It has a 50 ml mark in here. So I can fill this up with the slurry to 50 mils and just go along the spine like this in a very deliberate way to fill out the entire spine, consistent, right? And then I can go back with a spatula maybe and distribute the fibers, and that's pretty much it, right? Okay, so our next video is going to show how we make the slurry and the leaf casting process, either with the same video or after that, depending if the video is more than 5 minutes. I'm doing these very short videos right now. I'm not doing them too long. All right, so we'll see if we can squeeze that in, but if we can't, we can't. At least you get the idea here, is that 50 mils of the slurry should give you the 0.28 grams needed, right? Okay. And add water to them.